Hello and welcome to another hypothesis test example. So in this example, we have a study was run to determine if the average hours of sleep a night of Peralta students is less than 8 hours. A random sample of 50 Peralta students averaged 7.5 hours of sleep a night with a standard deviation of 1.7 hours. Can we conclude at the 5% significance level that Peralta students average less than 8 hours of sleep a night? So our first step is we need to understand the problem. So we are looking at if the average hours of sleep a night of Peralta students is less than 8 hours. This is a yes/no question. We're not asking what is the average. We're just asking if it is less than 8 hours. So this is yes/no. So we know that we are doing a test. We are dealing with the average. So we are talking about the mean. And then we just have one population, namely Peralta students. So we're looking at one population, talking about the mean, and running a test. From here, we have our random sample of 50 Peralta students, average 7.5 hours, with a standard deviation of 1.7 hours. So everything in this sentence is talking about the sample. So we know we have a random sample. Which is drawn from the entire population. "50 Peralta students is our sample size, so n equals 50. The average is our sample average, so x bar is 7.5. And the standard deviation is the sample's standard deviation. So we use S for sample standard deviation. So S is 1.7. So again, this is sample standard deviation. We don't know the population standard deviation. So this is when we use the t distribution. So for this, we are going to use the t distribution instead of the z distribution. The other key piece of information, we have 5% significance level. So we are looking at the 5% significance level. And then we want to know if the average is less than 8. So we are trying to see, is the average mu less than 8? From here, we want to write our hypotheses. So we have a null hypothesis and an alternative hypothesis. Our null hypothesis would be that Peralta students average precisely 8 hours of sleep a night. versus our alternative hypothesis is what our guess was. So that Peralta students average less than 8 hours of sleep a night. In terms of symbols, our null hypothesis, we are saying that the mean, so mu, is equal to 8. Our alternative hypothesis, we are claiming that the mean mu is less than 8. Next up, we have our justification. When we are talking about the mean, we need to both justify that we have a good sampling technique, so our usual checks, we need random, which we have, and drawn from the entire population. Which again we have. In addition to this, we need to have the normality of the now X bar distribution. Since we were talking about the mean, we should talk about the distribution of sample means. We had two options. Option one is if we are told the population data is normal, which we do not have that condition in this problem. Option two, we can go by the fact that our sample was large enough. So the sample was size 30 or larger. Okay. Our sample size was 50, so this is definitely true. So we have we can run the test. Because they used a good sampling technique. And the conditions for normality of the X bar distribution were met. And then I'm just going to add a little sentence here. We will run a t-test, meaning we will use the t-distribution since we only know the sample standard deviation. So we already mentioned this earlier. I'm just going to make a comment here just to keep it on record. Next up, step 4. We need to understand the sampling distribution. So again, in this case, we're talking about the X bar distribution since we are studying means. Our shape, we already know to be normal by step 3. The center, mu sub x bar is simply mu. So mu sub x bar, we are assuming to be 8. Again, this just comes from our null hypothesis. And then our spread, sigma sub x bar, we would usually do sigma divided by the square root of n, but we don't know sigma. So instead, I'm going to use what I call S sub x bar. This is not official notation. I just like to use this to keep track of the fact we are using S. So we should be working with the t distribution. So S sub x bar was equal to 1.7 divided by the square root of 50. And if we do that calculation, we wind up with about 0.24. So this is our standard error, or the standard deviation of the sampling distribution. From here, step 5, our job is to see where our sample fits into the X bar distribution. So we want to know, where does our sample fit in the sampling distribution? And is our sample surprising? So if we draw our picture, we have a normal distribution. 8 is in the middle. Our sample was 7.5. Our null hypothesis was that the mean was less than 8. So since the symbol is less than, we are looking to the left. So we are looking at the region to the left of 7.5. This is our X bar distribution. From here, again, we are stuck using t. We are going to translate to the t distribution. So calculating the t-score, we want to translate that 7.5. So we will have our sample 7.5 minus the mean 8 divided by the standard deviation of the X bar distribution, which we found was approximately 0.24. And this winds up being negative 2.08 approximately. So in our t distribution, we're looking at negative 2.08, and then looking to the left. The other big piece of information we need for our t distribution is what is our degrees of freedom. Our t distribution looks different depending on sample size. So our degrees of freedom, we're looking at n minus 1. So 50 minus 1 are 49. So we have degrees of freedom of 49. And then we're looking at a t-square of negative 2.08 looking to the left. From here, we should use the t-distribution calculator in Canvas. We know our degrees of freedom and we know our t-score. So if we go over to our t-distribution calculator, here's our t-distribution calculator. Our degrees of freedom was 49. And our t-value, or t-score, was negative 2.08. And then we were looking to the left. So the left, we have a 0.0214. So we are going to enter, I'm just going to record what we entered quickly. So we entered degrees of freedom of 49 and a t-value of negative 2.08. And then that gave us a left area of 0.0214. So if I go back over now to my other screen, so we entered again a degrees of freedom of 49 and a t-value of negative 2.08 and found a left area of 0.214. So since this is what we were looking for, this is our p-value. Our p-value is, in other words, 2.14%. This falls under our 5% cutoff. Again, that's just our significance level. So 2.14% falls beneath the significance level. So this is deemed rare enough for it to be surprising. If the null hypothesis were true. So since this is surprising if the null hypothesis were true, that makes us think that the null hypothesis is wrong. So our last step is our conclusions. So again, since we have surprising, that leads us to think the null hypothesis is wrong. And so we can go ahead and conclude our alternative hypothesis. So we can conclude at the 5% significance level, that Peralta students average less than 8 hours of sleep a night. So again, if we get that it is surprising, if assuming the null hypothesis is true, then that makes us think that maybe we were wrong about the null hypothesis and we should instead conclude the alternative. If we get that it's not surprising, if it does not fall below our 5% cutoff, then we simply say we don't have enough evidence to conclude. All right, so again, this was using t-score. The real main difference is that we use that t-distribution calculator. And the reason we had to do this is because we only had the sample standard deviation. We did not know the population standard deviation. So since we only knew the sample standard deviation, that's why we used the t-distribution. So that's another hypothesis test example.